to our third video notes for conic sections. This one is on ellipses. So an ellipse is a set of points P in a plane such that the sum of the distances from P to two fixed points, F1 and F2, is a given constant 2a. That is, the line segment distance PF1 plus PF2 is equal to 2a. And that's consistent throughout all of it. We're going to go watch we'll connect to another clip of me going through something else. So let's go do that real quick.
Just to kind of show the definition of ellipse a little bit better, remember the definition of an ellipse is that is a set of points P in a plane such that the sum of the distances from point P to two fixed points F1 and F2 is a given constant 2a. That is, this segment, PF2, and this segment, PF1, added together is that constant 2a. And a is the distance from the center to the vertex. Okay, so the distance from the center to the vertex in this ellipse is 8. So the distance of PF1 plus PF2 should be 16, which it is true for this. And you guys can see that this goes all the way around and that relationship stays true, which is really, really cool. Another nice kind of definition for a conic section that isn't something that's based on an equation. It's based on geometry, which is pretty sweet. And you can see that even if I put this here, the distance is going to be 8, 0, but this little segment here plus this big segment is still going to be 16, 2 times the distance. So that's kind of a cool relationship that you can have between two focal points. And if you guys watch that video, you would see that if these focal points would all be in the same center, so one focal point, you just have a circle, which is kind of cool.
Okay, welcome back. That was riveting, wasn't it? Alright, before we do anything else, I want to talk about some vocabulary, and there's some pictures over here. Pictures over here. Look at those pictures, they're amazing. We want to go through and talk about what the focus of an ellipse is. So this is the fixed point from the definition. So this is the fixed point. Okay, one of the two fixed points. And it's c units from vertex. And its plural is foci. Okay, because this is the first shape that we have two foci in our conic section. And having these two foci really kind of change what happens. So if you look at this picture here, you can see this is the distance c. Between these two things, there's our focus. This is distance b. This is distance a. And then 2a is that big distance, that constant term. Okay, so when we talk about a major axis, this is the longer axis. And it has a length of 2a. And we also have the minor axis. This is the shorter axis. And it has a length of 2b. And then my vertices are the endpoints of the longer axis. And the covertices are the endpoints of the shorter axis. Okay, and those are the properties. So essentially you can have horizontal ellipses, vertical ellipses, and that's pretty much it. Eventually we'll learn how to rotate them, but that's not this year. So the equations are pretty simple. They all have the same property of having a center at h comma k, where a is always greater than b, which is always greater than 0, and then c has this relationship to a and b. So c squared is equal to a squared minus b squared. And then these are the two equations. So our horizontal ellipse looks like this, and a vertical ellipse looks like this. They're actually literally the same thing. There's just a small difference, and it's wherever the bigger number is. So from here we see that a is always greater than b. Well, down here, notice how when the bigger number is underneath the y, it's vertical, and when the bigger number is underneath the x, it's horizontal. So a is always the bigger number, and a is always under the the thing that makes it horizontal or vertical. Okay, that's really all you got to remember. Okay, if the bigger number is under x squared, it's horizontal. If the bigger number is under y squared, it's vertical.